Hello everyone. In this project, we are studying about Relief Road Optimization Problem or RROP. The main goal is to find the best and shortest sea route for delivering food, water, medicine to disaster area. We want to make sure all help arrive fast and efficiently. This problem is similar to the traveling salmon problem, where the ship must visit every port once and return to the starting point using the shortest route. In this project, we use four locations, which is port A, port B, release sentence C, and release sentence D. The table of distance shows how far each port is from another. To solve this problem, we will look at five concepts, which is gradient algorithm, divide and conquer, dynamic program, backtracking, and sorting and researching. First concept we apply is gradient algorithm. The gradient methods make a quick and best choice at every step. It always pick the closest unvisited location next. For example, we start at point A. From there, find the nearest unvisited point. Move to the point and mark it as the visited. Repeat until all points are visited. Finally, return back to the point A. In the Java program, we use the distance metric to store the distance between point and visited list to track which point has been visited. At each step, the algorithm moves to the nearest unvisited point until all points are covered. So the final route for this project using a gradient algorithm is point A to point B to release sentence D to release sentence C and to point A. With the total distance of 188 nautical miles, this shows that gradient algorithm can quickly find the efficient and short route, making it the ideal for real-time relief operation where the time is critical.
Assalamualaikum, my name is Nura and Kisina, and today I will explain about the divide and conquer algorithm. Divide and conquer algorithm is a highly effective technique that simplifies complex problems by splitting them into smaller, solvable sub-problems, conquering each one individually and then combining the result to form the final solution. This method breaks down to finding the shortest delivery route. The divide and conquer algorithm in these Java programs work by breaking a large whole optimization problems into smaller, simpler subproblems that are solved recursively. The program begins at part A and mark it as visited before calling the recursive function divide and conquer bracket. Inside this function, the algorithm checks whether all ports have been visited. If they have, it calculates the total distance back to port A and compare it with the shortest distance found so far. If this route is shorter, it becomes the new best route. If not all ports are visited, the algorithm explores every possible unvisited port by calling itself again, adding the new distance each time. Once a complete route is tested, the progress backtrack, unmarking the last port to try other combinations. These programs continue until all possible routes have been explored, and finally, the algorithm identifies the shortest path are port A to port B to relief center D, relief center D to relief center C, relief center C will be back to port E with a total distance 88 miles. Lastly, the advantages of divide and conquer algorithm is for handling large independent dataset and can be easily parallelized for improved performance, but it suffers from high recursive overhead and is not ideal for a dynamic environment where continuously changing data can slow the process. Lastly, IROP, it is useful for pre-processing tasks like sorting location data or strategically splitting complex route zones before final optimization.
Hi everyone, my name is Siti Nabila binti Shamsur Anwar and I'll be explaining my part, the dynamic programming algorithm used in the Relief Road Optimization project. This algorithm helps find the shortest routes that visit all parts A, B, C, and D and return to the starting point. Here we define the number of parts and create the distance matrix showing how far each part is from another. For example, A to B is 15 nautical miles and A to D is 35. We also use two tables, memo and next node, to store route cost and the best next move. The program called TSPDP to calculate the minimum route cost. It used speed masking to track which part are visited. For example, 001 means only A is visited. The algorithm checks all possible routes and store result using memoization so it doesn't repeat calculation. This helps make the program faster and more efficient. One main advantage of dynamic programming is that it guarantees optimal result by reusing solution from smaller subproblems. Finally, the program prints the base route, which is A, B, D, C, A, with a total distance of 88 nautical miles. This shows the shortest and the most efficient path for the relief operation. In short, this algorithm help make relief delivery faster and more efficient by finding the best possible route for all destinations.
Hi, today I will explain about backtracking algorithm. Backtracking is a recursive method that explores all possible solutions by trying different paths. When it hits a dead end, it backtracks and tries another route until the best solution is found. In RROP, the backtracking algorithm is used to determine the shortest route for a relief ship that must visit each port once and return to the starting point. The program begins by defining a distance metric, which stores the travel distance between every pair of ports and a locations array that holds the names of all ports. The main method calls the backtracking TSP function, which analyzes the process from port A and uses a recursive function called TSP backtracking to explore all possible routes. Each time the ship moves to a new location, the algorithm marks it as visited and adds the travel distance to the current course. If the total course becomes greater than the shortest distance found so far, the path is pruned stop early to save time. When all locations are visited, the algorithm checks whether the road is shorter than the current best road, and if it is, it updates the shortest path and minimum distance. This process continues until all possible roads have been tested. In the end, the program displays the shortest route from port A to port B to relief center D to relief center C and to port A, with a total minimum distance of 88 nautical miles. This shows how recursion and pruning in backtracking can effectively find the most efficient path. The advantage of backtracking is that it finds all possible solutions systematically by making it suitable for pathfinding problems with constraints like RRP. It also ensures accuracy if a solution exists because it explores every possible route. However, the disadvantage is that it can be very slow for large datasets due to its high time capacity, which makes it inefficient for real-time execution even though it works well for testing alternative routes or scenarios.
Hi everyone, my name is Nurul Husna binti Roslan. I'll be presenting the concept of sorting and searching, focusing on inserting sort and binary search and how both are applied in the relief route optimization problem. Okay, sorting and searching are two important techniques in computer science. Sorting helps us arrange data in particular order, while searching allows us to quickly find a specific value with the data. Together, they make information easier to organize and access, which is essential for solving problems efficiently. In this project, we use insertion sort to organize port distance from shortest to longest. It assumes that the first element is already sorted and then take each new element and insert it into the correct position by shifting larger element to the right. For example, we start with the distance 35, 25, 15, 30, and 20. After applying insertion sort, they become 15, 20, 25, 30, and 35. The base case time complexity of insertion sort is O of n, and the worst case is O n squared. It works very well for small or nearly sorted dataset, making it ideal for real-time relief operation at sea where new data keep arriving. Okay, once the data is sorted, we can use binary search to find any specific distance quickly. Binary search work by repeatedly dividing the list in half until the target value is found. For example, if we search for 25, the algorithm checks the middle value 30, move left, check 20, and finally find 25. Its time complexity is O log n, log of n, which is much faster than checking each element one by one. Compared to other algorithms like greedy or backtracking, sorting, and searching are simple, faster, and more partial when dealing with larger set of data. Unlike dynamic programming or divide and conquer, which may require more memory or complex recursive structure, our approach focuses on data efficiency, making it easier to process, access, and analyze information quickly. In conclusion, each algorithm we explore play an important role in solving complex problems like the relief route optimization problem. The greedy algorithm offer fast, straightforward decision, divide and conquer especially break large problem into manageable parts. Dynamic program ensure accuracy and avoid redundant calculation. Backtracking explore all possible solutions to find the most precise one. And finally, sorting and searching make the overall process faster and more structured by organizing and retrieving data efficiently. By combining these different algorithm techniques, we achieve a balance between speed, accuracy, and efficiency, for allowing us to design smarter and more effective computational solutions.